Hello,
Hello.
am I audible?
Yeah, it is audible. Yeah, I'm listening right now.
Okay, let's begin.
I'm listening. I'm listening. Sorry, you can proceed the
Okay,
lecture.
thank you for your response. Today we are going to learn about distribution load flow as well as the optimal capacitor placement using genetic algorithm. And here we are going to learn the distribution load flow with the help of IEEE radial bus distribution system, which consists of 33 buses. I think I have not shared the screen.
Yes.
Okay, I will share entire screen so that the everything will be shared. Is it visual?
Yes, sir.
So let's open the MATLAB file. It is inside the MATLAB folder. MATLAB distribution load flow. While learning the distribution load flow, there is two kinds of methodology by which we can do the load flow analysis. One is that BIBC, that is summation of current method, and other is power summation method. Both are based on the forward and backward shift. That is, in one shift we calculate the losses, and in another we calculate the update the bus voltages. And initially we have to assume the all the bus voltage with that is having magnitude 1 pu and the angle 0, and these are the parameters that can be obtained from the net, as well as I will upload the file of this so you can get the distribution parameters. Here first column is line number, that is here for our easiness I have supposed that line number is receiving in -1. What is receiving in -1? That is, if we correspond with 24 bus number 24 and 25, then here the sending it is 24 and receiving it is 25. So this line number is 25 minus 1, that is 24. Again, if we consider two buses, that is 17 and 18 segment, then here the what will be the line number here in 17 and 18?
17.
Yeah. Okay. So likewise, the line number is considered. For example, you can see that first line number is the receiving is 2, so the line number is 2 minus 1, 1. Here we can differentiate here. Although up to 17, we can also say that the line number is equal to the sending in bus number, but it is not like that always, because in 18 line number you can see that the sending is 2, but the receiving it is 19. So 19 minus 1, 18. That's why I have already told that for our easiness, the line number is considered to be receiving in -1. L data underscore O, that is the parameters, consist of line number, sending in bus number, receiving in bus number, and corresponding resistance and reactance R and X. In any radial distribution system, always the line number is equal to the total number of bus minus 1. Because there is no any loop, that's why always line number is always 1 lesser than the total number of bus. Here also the total number of bus is how much? We can see from the figure, that is 33. So how many lines are there? 32 lines. So n bus will always be total number of line plus 1, which I have already explained. L data excludes the line numbers. It consists of only sending in number, receiving in number, and R and X. Now we have used the one function called app base config, and the input for that is L data and n bus. So we will go to the, here we have opened the base config.m. Now this is very important for understanding the load flow program. So finding the sending in nodes of the network. The network is IEEE 33 box network is given here. So how to calculate the sending in nodes? as we know that L data consists of what? Sending in node, receiving in node. First column is sending in node, second column is receiving in node, and third and fourth are R and X. So, and L data is passed through as an argument in app-based config. So, in app-based config, here also for our easiness, it is given the L data is L data only, and the number of bus is N. So we can segregate sending in node by copying first column from L data, because first column consists of sending in nodes. Like that, receiving node is in second column. So from second column we can calculate receiving in node. And also line resistance is third column, so we can copy from L data, that is copying third column. Again, reactance, line reactance is given in fourth column, so we can easily copy that from copying fourth column from L data. Now we are going to find what is a starting node of the network. By seeing it only, we can observe that the one is the starting node. But in logic, how to find that the one is only the starting node? For that, we can develop one logic. That here we see why 2 is not a starting node, because 2 is fed from 1. But 2 is fed from 1. So the node which is not fed from anywhere, that is, if the node which is fed from anywhere, that corresponds to the receiving in node. No, we have calculated Rn as the receiving in nodes. So the node which is not consist in Rn, that is the starting node. So we can calculate a starting node by this logic. That is, we have to run the loop from 1 to number of bus, and if in all that bus, here we have to understand this code. It is given that if I is equals to Rn, that means in Rn consists of how many members? That is 32 members. 32. So if I is equals to 32, then their value will be 1. For example, let's suppose A equals to 1, 2, 3, 4. A equals to 1, 2, 3, 4. Now, if I calculate 1 equals A, then what will be the result? See, that is 1, 0, 0, because 1 is in first place and other will not be equal to 1. That's why it becomes 0. Now maximum will what will the maximum will give? Maximum of all result of all these 4 values. That is, if we insert here max, max max, then we will get 1. That is 1. So here we have equated now 1 equals Rn. If the maximum of 1 equals Rn is equal to what? 0. That means it is possible only when nothing is corresponding in Rn. That is, that I which is not belongs to Rn, then only this code will give this maximum in bracket I equals Rn will give 0. So as I already said, a starting node is that node which does not consist in or does not belongs to Rn, receiving in nodes. So if I does not belongs to Rn, then this code will give the result 1, and that we have to store in S. So, and we know that in radial distribution system, there is only one starting bus. So after getting that, storing that starting bus, we don't have to go again for checking again and again, because Whenever we get 1, after that we won't get anything because starting node is only 1. So like this you can calculate a starting node. Now it will go further, that is in nodes. Here also, what is the in node? That is in the laterals. How many laterals? 4 laterals. That is was now which one is in nodes? 18, 22, 25 and 33. But in program we have to develop a logic. What are the in nodes? How we can say what are the in nodes? Like a start node, we have to develop a logic. That is, we can simply say that the node which does not feed the power to any other node are called in nodes. That is, it is only in receiving node, not in sending node, because in nodes does not send any power to other node, any other node. So here also we can run the loop and find that those nodes that is not in sending nodes. Those are called in nodes, which is given here. First of all, we have to initialize number of in node 0. Then we go for the for loop 1 to n and calculate this. That is here. Again, we can see that it is similar to that of which we have learned previous. That is, maximum I equals Rn was there in earlier case. Here is Sn. So those I which does not belong to Sn, then only this if clause will be satisfied. And then we have to store that node, and the number of in node will be increased by 1. So as we already see from this figure, that in node can be greater than 1 also. So we have to check for every nodes. We cannot use break command here. So after checking all the nodes, this code will give us the total number of in nodes. That in case of this figure, the total number of nodes is 4. That is 18, 22, 25 and 33. Now, again we go further, and that is finding of the precedence node. What is this? Precedence node means sending node of corresponding bus number. That is, in given figure, the precedence node of 25 is 24. Likewise, precedence node of 19 is 2, because 90 is fed from 2. Again, precedence node of 15 is 14. Likewise, and so on. So how to find this? Now, so one thing we have to keep in mind, that a static node does not have any precedence node, because that is not fed from any other bus, a starting node. So that is, this is except a starting node. Now we have to again run loop from 1 to n total number of bus, and for those i's which is not equal to s, that is that I which is not the starting node, because we have already learned that a starting node does not have any precedence node. So we have to understand this code. What do you mean by this? Here we have used the find. Find will give the indexing. Find you will give the index. So, and other one thing we can learn from here, for showing that I will use the line parameters. Here you can see that for a radial distribution system, not a loop, but for radial distribution system, the receiving in node is unique because there will be no repetition. This is unique. There will be no repetition in case of radial distribution system. But we can see in sending node there can be repetition because here we can see that here is 6 and also here is 6. So 6 is going to be repeated. Likewise, 2 and 3 are also going to be repeated because here is 2, here is 3. So this is not unique. Sending in node is not unique. That vector array that is not unique, but the array of receiving nodes is unique. Otherwise, radiality will not be maintained. Here we can see that since this is Rn is unique, so if I belongs to the Rn, then I will equal to the only one member of Rn because all are unique. So no two members of Rn will be equal to I. And find this will give the index of that member of Rn which is equals to the I. And why we are going to see this? Because we are going to find the precedence node. Let's see from the example how you can find the precedence node. For this, first of all, we have to know the suppose we have to know the precedent node of 26. So how we can find the precedence of node of 26? Here we can easily find from the picture that is 26. Precedence node of 26 is 6. But in program, how you can find this? By developing a logic. For that, first of all, we have to assume that the 26 is the receiving node of which line? That we have to find. For easiness here, we know that the 26 is the if the 26 is the receiving node, then that corresponding line is what? -1, that is 25. But it may be different in other networks. For easiness, we have assumed like that, but for general, we have to write the program for general purpose that can be used for any network. So it is not necessary that receiving in net line number will be always receiving number bus number -1. So we have to develop a general logic. For that, we can say that first of all, we have to see the 26 is receiving node of which line. So we have to equate that receiving node. Suppose I is that receiving node number, then we have to equate I to the Rn because Rn is the unique array. So it will correspond to only one point, or I will be equal to the only one member of Rn. So, and the index will be governed by the find. Now, this code find, complete code find I equals Rn will give. This will give us the line number because we know that from figure the index in Rn 2 has how much index? 1 index. Index number 1. 3 has index number 2. Indexing 1, 2, 3, 4 like that. And here we can see that the line in number is also like that only because 2's index is 1 and line number is 1. 3's index is 2 and line number is 2. So index of receiving in node is equal to the line number in our case. That's why like that we can find the line number. So after getting line number, if we know the line number, then we can also find the sending in node, because in sending in node, if we will give the line number, then we will got the sending in node. That is fourth have how much? 4. Like that. Here in the 22, what is the sending in node? 3. We can easily get. So we have to give the index into the sending in node, then we will get the that sending in node. So here for I, the preceding node is that sending node whose receiving end is I. So Pi fetch the power to the node I. This is the meaning of precedence node. So let us learn about the finding the continuous path, lateral or trisets. That is how the lateral is connected, how the buses in the lateral are connected to each other in ascending order or descending order. Here NCU is the number of components used, and UCA, that is used component ascending order, and likewise after finding that we can also find in descending order too. After that we will find the branch. Here this is the used component, means the used bus. Here C correspond to the bus number. These are the connected to bus, and here B corresponds to the, this is the branch number, branch, B for the branch, and branch in descending order. Why do we need this? Because we have to calculate the power summation from in to 1 up to 1 for each branch, how much power is flowing. So we have to calculate by the summation, power summation method. Now let us explain this code. Here we have run the code from 1 to in node, because number of in node is equal to the number of laterals. Because here we can see that how many laterals are there? 4 laterals, because there is 4 in nodes. If there will be 5 in nodes, then there must have the 5 laterals. So now we have to, for each lateral, we have to calculate the see the arrangement of buses. And in each lateral, now let's see from this figure how we can calculate the number of buses in each lateral. So suppose we have chosen 18 in node, then we have to find the precedence node of 18, then precedence node of, that is 17, and then precedence node 17, that is 16. Likewise, until the starting node is, we get the starting node, we have to goes on chain and chain and chain, so on. That is from 18 we go to 17, then 16, and so on up to the 1. Likewise, in this lateral, in node is 22, then preceding node of 22 is 21, then 21 is 20, then 24, 20, that is precedence 19, for 19 precedence node is 2, and for 2 it is 1. So we have to see all the precedence node until the starting node is, we achieve the starting node, or we go up to the starting nodes. So here we get 18, 17, 16, 15, and 1. For each in node, we have to calculate the other precedence node up to starting node. So here again for each node, we have to run for that 1 to total number of bus, and m is also 1 to total number of bus. Here we see that if m equals px, that is if m is the precedence node of x, that is for first time that will be any one in node. So if m is the precedence node of this, or px equals 0, that is we have come to the 1. For precedence node 1, starting node, we have assumed that precedence node is 0. That is we have come up to the start node. Then number of component used is 0 plus 1 1, and we have to save UCA in ascending order, that is x. We have to save the x and see that 1 comma 1 will be this, then 1 comma 2 will be precedence node of. We have given x equals px, that is we have updated now. In x we have put the precedence node of x. Again, now the precedence of node of x is in x, so if the 18 was the in node, then we have to come to the 17. Then again for that also we have to calculate. We have to find which m is equal to the precedence node of 17. For this example, given example, that is 16. 16 will be the precedence node of 17. And likewise, when it comes to the one start node, then the precedence node will be one of precedence node of start node will be 0, and it will be this lateral will comes to the end. We have found all the component, all the buses which belongs to the this lateral. Then likewise we have earlier calculated all the in nodes, that is 4 in nodes. So after calculating for in node 18, this program will calculate for 22, again 25 and 33 and so on. Then arranging the laterals in the descending order. We need in descending order because for the power summation, if we neglect the losses, then what will be the power summation? For this branch, the power flow will be load of 18. For this branch, power flow will be the, how much will be the power flow? That is sum of the loads of 17 and 18. Likewise, we are just reversing the values. Again, for the branches, this code, I think this is the familiar code. That is anything equals Rn. That will be the branch number. So like that, from the bus number, that is bus number NBU, number of components used. So here is the UBD is used branch in descending order. And from UCD, we will calculate now. One thing, this is very important, that is N matrix, because it helps us in the power summation as well as the interconnection of branches. NMat is like this, we can see that NMat is N into N matrix. That is total number of node times total number of node. It is a square matrix, consists of N into N, total number of node by total number of node. Here, two things are important. One, it will give the information about, if you consider that, let's suppose bus number 1, then this NMat will give the information that which bus fetch the power to the bus number 1. For this given figure, only bus number 1 fed the power to the load of bus number 1, not other one. But bus number 1 feeds the power to the load of every bus, because for other buses, the power must go through the bus number 1. But for bus number 1 itself, only power load of bus number is fed through the bus number 1. So those two information is can be found from the NMat. That is, if you consider bus 6, then power fed from which bus? That is, the for load of bus 6 will get the power from delivered from 1, 2, 3, 4 and 5 as well as 6, because power must flow from 1 to 6. For getting the power in the supplied to the load of bus 6, the power must flow from 1 to 6. And also, which load of which bus will get the power through the 6 bus? That is, load of 6 bus up to 18, as well as load of the buses from 26 to 33. That will be fed from the bus. Power must go through the bus 6. These two information will get from the NMat. I think this will be the end of base configuration. After that, distribution load. After calling this base configuration, this function will get these things: sending in node, receiving in node, that is line resistance, line reactance, starting node, number of in nodes, precedence node, number of component, how many buses are used in the lateral, how many branches are in lateral, and another NMat. That is information about the load of any node is being fed from which buses, and also load of which nodes is going to fed through that bus. Those two information are given from the NMat. First of all, let's run this program. Here I am going to explain you about the NMat. What is the NMat? NMat. Column, how many columns? 33 columns, and rows are also 33. Now see, upper row, every element up to here is 1, and also the remaining 19 to 33 are also 1. That means, let's go to this figure. The load of every node is fed through the bus number 1. The load of 1 also is fed from bus number 1, and load of other nodes are also, the power must go through the bus number 1. That's why all the elements of row, first row are 1. That is, every load, whether it is in 1, 2, 5, 6, 7, in any load, power going to that load must flow from the bus number 1. What do you mean by the column? That is first column. Here we can see that only first element is 1, or all others are 0. That means, as I have already said, that means column corresponds to the, for example 1, the load of 1 is fed through which buses? For this figure, the load of 1 is fed through only bus number 1. That's why in the first column, only first element is 1. All others are 0, because load of 1 is not fed through the bus 2 and other buses. So I want to ask one question. For 19th row, which element will be 1? Because in any row there is 33 elements, and in any column there is 33 elements. So row corresponds to what? The 19, the load of which is fed from 19, that will be 1. Then in 19th row, the which column have the 1 value? Then 19 itself, 20, 21 and 22, because those are fed from the, always power go from 19 bus. Again, for 19th column, which row have 1 number, then that will be That is 1, 2, and
1,
19.
2.
And 19. So for 23, in 23rd row, which column have the value 1?
23, 24, 25.
Okay. In 23rd column, which row has value 1?
1, 2, 3, 23.
Okay. Now we can understand the load flow easily. So let's go to the app distribution load flow. Here, boss data is given. Boss data corresponds to which? That boss number and the loading. That is P and Q. Kilowatt and these are kilowatt. P and Q. How many buses are? 33 buses. And that is IEEE 33 bus system is a of how many voltage level? 22.66. These are converted into PU so that our calculation will be easier. After converting in PU, as I have already mentioned, this load flow is power summation method as well as it is also based on the forward and backward sheet. First of all, we have to assume voltage of all the buses have magnitude 1 and an angle is 0. In first go, we have to calculate the summation of power for each in node, for each lateral. Suppose for each lateral, we have to calculate the how much power is flowing to which branch. Every lateral, one by one, we have to calculate the power flow through the each branch. So for first go, we'll assume that there is no any losses, branch losses. That means for example, for this branch, what will be the branch number of this?
14.
14. Yeah. So for this branch, how much power will flow in initial case? The summation of load which are fed from this branch, that is 15, 16, 17 and 18. If we sum up all the loads, then that will give the power flow through this 14 branch, which is given in this one. This code copies all the CRN rows elements. That means if the CRN is first, then it will copy all the first row. CRN is, let's suppose 10, then it will copy all the 10th row. And we have seen that the rows values are what? Which buses loads are fed from that bus, those value will be 1 in that particular row. So after summation of load of those buses, whose value is 1, then we will get the total power flowing through that bus. If the ROW1 equals 1, what do you mean by this code? Here, if the L, this is L is running from 1 to N node, total number of node. If L equals CRN, that is, we are calculating the power summation. Let's suppose we are calculating the power summation from bus number 23. So which elements in the row will have, or which column in row 23rd will have the value 1, that is 23, 24 and 25, because the load of 25, 24 and 23 is fed from most power flow through the 23rd bus. Here the current node is, we are calculating that power summation for 23rd node. Current node is 23. Now, if I is equal to this, then here we are not taking the losses, because if we are calculating the power flow through this bus, 23rd bus, then for power supplying from 23rd to the load of 23rd, there won't be any losses. But when power will flow from 23rd to for feeding the power load of 24th bus, then there will be loss in this branch, 23rd branch. And again, for 25th also, if the power flow through the 23rd to 25th, corresponding loss will be also there in 23rd branch. But for feeding the load of 23rd, there won't be any losses. L is the current branch, then we don't have to consider the losses. But if it is not the current branch, and one thing we have to keep into mind, we have to sum the power or losses only when whichever elements have value is 1. For that buses only, we have to add the power as well as the corresponding losses of the branch. And this is the formula that is obtained from the, if you consider only two bus system, then we can obtain this formula. That is, power is going to A to B, and then we can, by equating one equation from current, that is, we can equate that current flowing through that branch will be sending in minus receiving in by impedance. And another current can be found from the power also. And by equating those two equations, we can get this equation, this formula. We have very long formula for receiving in voltage. We have taken this portion and again we have calculated this one. We know that the voltage magnitude cannot be imaginary. So if a quadratic equation is ax square plus bx plus c, then characteristic equation, that is b square minus 4ac, must be greater or equal to 0. Otherwise, the roots will be imaginary. That means load flow is not converging. Again, we have to calculate IMGG, because at last the voltage is a square root of IMGG. So any up to this, IMGG also should not be less than 0. If IMGG is not less than 0, then only it guarantees that the voltage magnitude is greater than 0, that is, it is positive. Magnitude cannot be imaginary, that is, a square root of negative must be imaginary, so IMGG must be positive or 0, greater or equal to 0. After calculating V2, the difference of angle can be easily calculated with this formula. Here we can see that only V2 is required. And the formula of V2, we can also see only V1 is required for calculating what? V2. Only V1 and all the line parameters as well as power summation. So if the power loading, we know the loading of each bus, and if we know the sending it bus, then voltage of receiving it bus can be calculated. And we already know that the starting node have 1 at angle 0, because it is already mentioned the bus voltage of a starting node, because that is slack bus. So if the, for example, in given figure, if we already know the bus voltage and angle of 1, then we can calculate it for 2. If we know for 2, we can calculate for 19, 3, and so on. So after calculating all the bus voltage and angle, updating this one, after updating all the bus voltage, other bus voltages and their corresponding angles. And now it's time for calculating losses. So branch loss can be calculated. Active power loss will be simple, S square by B square into R. That is I square R. And reactive power loss is I square X. After that, we have to store that data. Power through all the buses will be the previous power flow plus the losses of corresponding branch. Then this load flow will, again this will be go and go and go on until error becomes within the permissible limit. Here we have calculated voltage error, that is real error, that is error for angle as well as error for voltage magnitude, and we have calculated maximum, how much the maximum error, and that maximum error must be within the tolerance level. If that becomes under tolerance level, that is we have kept is 10 to the power minus 4. If the max error is within this range, then we conclude that load flow is converged. Now let's run the load flow. So once we have calculated the power summation, and after calculating the power summation, we have updated the voltage from a starting node to voltage of all other buses. And after updating, we have again calculated the losses. Then new power flow will come. For that power flow also, again we have to update the voltages and calculated the error. How much difference is coming from previous value, updated value, to the current obtained value. And if the error is within the permissible range, then we conclude that the load flow is converged. That is, what do you mean by error is less? That value is not changing. That means the true value has come. So let's run this program. Again, one thing I have forgotten to mention, that is we have also plotted the bar graph of voltage. That is here. VCT TMPV. X-axis is 1 to 33 because there are 33 buses and value is from 0 to 1.1. Y-axis. And here is the result. That is, how many iterations we have? It is taken only 4 iterations. Maximum error is this much only. Here are the load flow result. That is bus number, voltage magnitude, and corresponding angle in radian. This is the active power flow and reactive power flow of the branches. This is sending and receiving node of branch. Sending in branch number, receiving in branch number, and this is the real and reactive power flow. And we have calculated the total power loss is, active power loss is 210.99, almost 211 kilowatt, and reactive power is 143.033 kilowatt. So this is the load flow IEEE 33 bus system. For different bus system, just only we have to change this line parameter as well as this bus data. After changing these two datas, we can easily calculate the load flow of any radial distribution system.